Finally, suppose that your real situation falls between those in panels A and B. You don't make all the money you expect to make this summer or next summer. Rather, you have an employer that will pay you $5,000 this summer and then $5,500 next summer. Your endowment bundle will once again be the consumption bundle at which you have to neither borrow nor save. Since you make $5,000 this summer and $5,500 next summer, your endowment bundle is therefore bundle E double prime, the bundle where you consume $5,000 now and $5,500 next summer. Notice that bundle E double prime is available to you regardless of what the interest rates are in the economy, because in order to consume bundle E double prime, you have to neither borrow nor save. Next, suppose that you could both borrow and save at 10% interest. If you took your $5,000 that you make this summer and put it in a savings account, next period, that is next summer, you'd have both that $5,000 plus $500 in interest in that account. Added to the $5,500 your employer is going to pay you next summer, that would enable you to consume as much as $11,000 in other consumption next summer, assuming you're willing to consume nothing now. In other words, you could consume bundle B. Alternatively, you might go to the bank and try to borrow on the $5,500 that you are going to make next summer. The bank would be willing to lend you up to $5,000, because knowing that you're going to make $5,500 next summer, the bank knows that you'll be able to pay back the $5,000 plus the 10% interest of $500. Added to the $5,000 you're already making this summer, this would enable you to consume up to $10,000 now if you're willing to consume nothing next period. In other words, you could consume at bundle A. Or you could do something in between bundles B and A along the blue intertemporal budget constraint that corresponds to the 10% interest rate for both savings and borrowing. Notice again the slope of this blue budget constraint. It's minus 11,000 divided by 10,000, which is minus 1.1, or minus 1 plus 0.1, where 0.1 is the interest rate expressed in decimal form. The intertemporal budget constraint therefore once again has a slope of minus 1 plus r, just as it did in panels A and B. The reason for this is that once again the opportunity cost of consuming $1 now is that you're giving up 1 plus the interest you could have earned on that $1 next period. Next, suppose that the interest rate for both borrowing and saving falls from 10% to 5%. We know that's going to change the slope of the budget constraint from minus 1.1 to minus 1.05. In other words, the budget constraint is going to become shallower. We also know that budget constraints always rotate through endowment bundles when prices change, because endowment bundles are always available to consumer regardless of what prices are in an economy. Thus, the budget constraint now has to rotate through E double prime, while it becomes shallower. We therefore get the new magenta budget constraint as the intertemporal budget constraint when the interest rate for both borrowing and saving is 5%. This change in the intertemporal budget constraint as the interest rate falls should make sense. If the consumer consumes less than $5,000 this summer, that means the consumer is saving money, and a decrease in the interest rate will mean the consumer won't get as much savings as she would have at the higher interest rate. Thus, bundle B shifts down to bundle B double prime. On the other hand, if the consumer consumes more than $5,000 this summer, it means the consumer is borrowing money. And when you're borrowing, a decrease in the interest rate is a good thing. You'll be able to borrow more money. Thus the bundle A shifts to bundle A double prime. In order to locate an intertemporal budget constraint, you therefore really only have to know two things. First, you have to know the interest rate, because that determines the intertemporal trade-offs a consumer faces, and therefore determines the slope of the intertemporal budget constraint. Second, you have to know where the consumer's endowment bundle lies, which is just another way of saying you have to know in which periods the consumer earns income. For instance, the consumer might earn income only this period and then plan to live off of savings in some future period. In that case, her intertemporal decision is really a savings decision, because the only way she can consume in the future is if she in fact saves now. Alternatively, it may be that all the income happens in the future, and in order to consume now, you have to borrow. In that case, a case like panel B, the intertemporal decision is really a borrowing decision. Or it might be that we find ourselves in some case in between, where you earn some income now and some income in the future, and we have to decide whether we should borrow or save, depending on our circumstances. That's a case like the one illustrated in panel C, where to the left of E double prime we're saving money, and to the right of E double prime we're borrowing money. Notice that to the left of E double prime in panel C, the picture looks a lot like the picture did in panel A, because that's where savings happens. To the right of bundle E double prime, on the other hand, we're borrowing, and the picture looks a lot like panel B, where we analyzed a pure borrowing decision.